In this video, let us understand what is actually hierarchical clustering is. Let us draw an axis here. Let's say we have our data points inside this graph A, B, C, and D, and we have here E. I'm going to represent these points here in the single line to draw a dendrogram. Now, here the points A and B are near so that I can form the cluster. So here I can represent it as like this. Now similarly, C and D also form a cluster. So C and D also will form a cluster. This I can represent in dendrogram like this. Now this cluster is near to the point E so that I can just merge and form a whole as one cluster. Now here in dendrogram I can represent it as like this. Now we can form the whole as one cluster. In dendrogram I can represent that like this. Now initially we have formed AB and then CD and then C, D and E. Finally we have formed with A, B, C, D and E. This is how it looks in dendrogram. Now here the ultimate goal here is to find out the K value, right? So we need to find here, for that we need to find the longest vertical line that has no horizontal line passing through it. If you look at this diagram here, we have here this, it is passing through horizontal line. This also passing through an horizontal line. So the one which is not passing through an horizontal line is this. So here I can take the mid value of this line and point out 2 points. Here it says that my K value will be 2 here. So likewise, I can just select the K value. Now let's look at a mathematical example, mathematical intuition behind hierarchical clustering. Now let me take a data set here, which is having X and Y axis. Now let me bring it here onto the screen. So we have here X and Y points. Now I would like to find the distance between P1 and P2, P1 and P3, P1 and P4, likewise till P6. For that, I'll be using here Euclidean distance. Now, distance between P1 and P2 can be written as 0.22 minus zero point 0.4 whole square plus 0.38 minus 0.53 whole square. Now I will have my value as 0.23. Similarly, I can find the distance between P1 and P3. Now I will have my Euclidean distance 0.35 minus zero point 0.4 whole square plus 0.32 minus 0.53 whole square, where I will have a value of 0.22. Similarly, I'm going to find the rest of the distances between all these points. Now finally I will have a matrix like this. Let me just paste that here so that I can save my time here. So finally we have a matrix like this, which where you are seeing it on the screen here. Okay. Here we have a matrix. So first of all, the distance between P1 and P1 will be 0 because it's its own point. So distance will be obviously 0. Now distance between P1 and P2 we have found out it is 0.23. Similarly between P1 and P1 and P3 we have got 0.22. Similarly we would find out all the points between these P1 and the rest of the points. Will get all these values. Right. Now here we would like to check the minimum value in the matrix. Definitely zero point 0.1 will be our minimum value. So here in this case we would like to eliminate a P6th row. We are going to eliminate this row and this column, and we are merging this P6 with P3. Now this will be eliminated from our matrix. Now let me show the updated matrix will be shown as like this. So now my updated matrix will be like this because I have eliminated P6 and merged that P6 in P3. All right. Now similarly, we are going to do the same thing with this matrix. Now here we are trying to find out the minimum value. So we find out the minimum value in this, which is having here 0.13. Now we are going to eliminate the row P4 and also the column P4, and we are going to merge this P4 in this row and this column. So in our next updated matrix, we'll be looking something like this. Updated matrix will be looking something like this. So this will be my updated matrix. So you can see it here. Our P4 row and column got deleted, and we just merged P4 with P3 P6 row and P3 P6 column. Now again we would like to find out the minimum value. You can see it here, zero point 0.4 we have twice here. But if we put the values after decimals, this is actually the lower value. Now we are going to eliminate this P5th row and P5th row from here and P5th column from here, and we are going to merge this with P2. Now P2 and P5 will be updated as a separate matrix. Now let me just paste that and show you how finally the matrix looks like. Now finally my matrix looks like this because we have merged our P5 with P2 and eliminated the P5th column and P5th row. Likewise, I'm going to do for the rest of the things until it gets a matrix something like this. And our final matrix will be something like this. Right. Now, if you put this everything in a dendrogram, we can just see that here. Now you can just see this the same kind of operation in dendrogram. So here when you look at P3 and P6 form the clusters, okay, and then with P3 P6 we have formed the cluster with P4, and then with P4 with all these three clusters we have formed the cluster with P2 and P5, and finally as a whole, like with P1 we have formed the rest of the clusters with P2, P5, P3, P6, and P4. This is how actually the dendrogram got formed. All right, this is the mathematical intuition behind hierarchical clustering. I'll see you with some more videos in our next video. Thank you for watching.